Okay, so today we have a very distinguished lineup of researchers who have known Avi and worked with him and who agreed to come and talk to us. We are very fortunate to have them here. Their calendars are booked for years in advance, but it was very easy to convince them to come. So I think it's not my charm, I think it's their appreciation to Avi's work and life. So I think what we will do next, and I think if Avi was here, he would be very excited to hear the talks that are coming up. So we will immediately proceed to our first talk of the day. I'm very proud and happy to present to you Professor Ron Dahl. He's a world-renowned expert in adolescence brain development, emotion regulation, and early intervention and prevention. He has published over 350 papers, and is the director of the Institute of Human Development at the University of Berkeley. He's a fellow of the American Academy of Pediatrics, American Academy of Sleep Medicine, New York Academy of Science, Association for Psychological Sciences, just to name a few. It goes on and on. He's the founding editor of Developmental Cognitive Neuroscience, and he's the president of the Society for Research in Child Development. And please welcome Professor Ronald Dahl.
Thank you. It is it's an honor to be here and be part of celebrating Avi's life and his contributions in all the ways that have been mentioned, as a scientist, as a clinician, as a mentor, as someone who cared about science and the truth. And I also want to thank Yair, and this is the advancer.
Let me just turn it
on. Okay. Also, Yair created an emotion regulation task for all of us by asking us to talk about science after a very emotional introduction and stirring of memories and feelings. And luckily, my deepest interest in emotion regulation is not about cognitive control of emotion, but using emotion as wind and sails to be effective. And so let's use our emotion in that way. And I'm also very, very interested in the affective dimension of motivation. Two of my favorite quotes, one by Maya Angelou. I've learned that people will forget what you said, people will forget what you did, but people will never forget how you made them feel. I think that's a very wise and deep observation, and obviously the people that we care most about, we recognize that it's not only what they did for us and what we did with them, but the feelings they evoked. And then a related set of ideas and quote is really, as Aristotle noted thousands of years ago, that thought by itself moves nothing. Without feelings, feelings of desire, there was a Greek word that he used actually for this concept. Human capacity for rational thought would lack any power to act. It is this dimension of feelings that provide the positive energy and force for those things that we do, and our ability to use our emotions, not just to control them, but to channel them is as important as anything we do. So with that as a segue from channeling a lot of emotions personally at this time, I want to give you an overview of what I'd like to talk about in the next 45 or 50 minutes. I decided to give a very, very broad overview that relates to several things I've been involved with and numerous intersections with Avi. But it's really to think about transdisciplinary developmental science. And what I mean by that isn't just interdisciplinary. It's really this transformational integration across levels. It's deepening our mechanistic understanding of development. It's integrating different levels of that understanding and translating it to broader areas of practice and policy. And this framework of transdisciplinary developmental science is the most important thing to me and for our research group and for our collaborations. Within that broad frame of transdisciplinary developmental science, I want to focus on the onset of adolescence, very specifically the transition from childhood into adolescence, this onset of puberty, as a key inflection point. Not because it's the most important time in development, or it's more or less important than the first year of life or the readiness for school, but rather it is a particular period of development that allows us to understand complex processes that create an inflection point for modifiable improvements and preventing negative spirals. Within that focus of this inflection on the life course trajectory, I'm going to talk about two dimensions. The first, focusing on sleep arousal and affect regulation during that transition, which has been a focus of my work for about 10 or 15 years and overlapped a lot with my collaborations with Avi. And then in the last 10 years, a broader set of questions about social, emotional, and motivational learning during pubertal maturation and the unique insights this creates as a window of opportunity. So that's the big map of where we're going. Again, this idea of transdisciplinary developmental science is the deep principle that runs through all of this. And I feel very fortunate because when I started my career, more years ago than I want to count back to, I focused on sleep. And sleep was a very fortuitous thing to be at the center of my interests because it created a natural ability to do transdisciplinary work. Because at that time, there were compelling scientific mysteries and frontiers. We knew so little about the function of sleep, the role of sleep in the developing brain, how exactly sleep worked, why it was so important across species, and why it was important in development across species. And so it was a compelling scientific frontier for deepening our mechanistic understanding. But it was also enormously practical. As was outlined in your wonderful introduction of Avi's work, spanning these different areas. I mean, to do clinical work, to do policy work, the part of it that overlaps with pediatrics, that overlaps with psychiatry, overlaps with psychology, thinking about family systems, behavioral science, neuroscience. It's such an integrative area with the ability to do the cutting edge basic research and the practical clinical and policy work was doable in this area. And it was also a wonderful opportunity to understand the development of regulatory systems and their interrelationships between sleep, stress, and emotion regulation. And I feel very, very fortunate that was where a lot of the formative experiences occurred for me in my research career. And that was what brought me very deeply intertwined in Avi's life. And we collaborated on many projects, and including interest in infant sleep and family interactions and treatment in that area, but then increasingly this focus on the onset of puberty and adolescent development and as this pivotal period of time. And this is a schematic. Let me see if I can get the, I was going to try to get the pointer, but I think I can also use a mouse. I can also use this. So this broad visual graphic represents probably about 10 or 15 years of my life, taking different slices across these complex interactions between sleep and arousal regulation and sleep and affect regulation. And obviously sleep has many components, different types of sleep, circadian system, the depth and disruption, the continuity and patterning of sleep. All of these are important. And how it interacts with affect, whoops, I did not want to switch. Let me go back to different aspects of affect, from arousal to emotion to the affective dimension of motivation, and then affective regulation, flexibility, and skills, the interaction between cognitive processes and these affective and sleep interactions, and the developmental trajectory. And we were very interested in clinical policy and early intervention and prevention. And again, I probably contributed to 100 papers in looking at different aspects of these questions, going from the basic understanding of developmental changes to their interactions to the clinical and the policy implications of that work. But what became the focus, the primary focus during this period of time, was really thinking about, more specifically, how these interactions changed during adolescent development. And we became increasingly interested in interactions between sleep and arousal systems and vigilance and affect regulation, particularly at the onset of puberty, and diving more deeply into mechanistic understanding of this. And one of the big frameworks that was very important for both the clinical work as well as our research was the opponent process interaction between sleep and arousal. Sleep isn't just stress. Sleep is losing awareness and responsiveness to the external environment. One should not, I don't know why this is an automatic advance, I think, but one should not turn off vigilance unless an individual is in a safe environment free of threats and predators, and every species solves that in different ways. And for humans, this vigilance that is counter to sleep changes at the onset of puberty in some very interesting ways, and it has a lot of clinical implications because the threats are not physical threats, they're social evaluative threats. And so the feeling of connection and belonging, feeling valued, suddenly becomes intertwined with the deep sense of feeling threatened. There's a reason that we can drive 60 miles an hour or 70 miles an hour on the interstate and fall asleep, but stand up in front of a group of people and give a talk and your heart rate and arousal will be very, very high because social evaluative threat is deeply wired to produce high arousal. And similarly, the disruptions in our sense of belonging and connection are disturbing to sleep. And we became very interested in understanding this broadly and in understanding the puberty-specific changes in sleep, in vigilance systems, and in the circadian system and their interactions. Now, I'm just going to give a broad overview of some of this work. Most of this, I mean, this is all the field's work, not my work. There are many people that contributed to this. Oscar Yenny is another very good friend and colleague. His lab did key aspects of this work. Mary Karskadin did key aspects of this work that I'm talking about now. But this disentangling, not just what happens in adolescence, but what happens specifically as puberty begins, became an interesting focus of this work. And what Oscar's group has shown is that there are very specific changes in slow wave activity and deep slow wave during this pubertal maturational change. And they modeled this in very rigorous ways to show that it was, in some counterintuitive ways, not actually the decay. It's not that actually a sleep process that changes, that as you change the amount of time that young people are awake, and you do it when they're Tanner stages 1, pre or early puberty, to Tanner stage 5, late puberty, it's not the decay of that slow wave accumulation, it's actually the rise time constant. It's actually changes in wakefulness accumulation of the pressure to sleep that's actually changing. And as we look at the circadian system, it became even more intriguing. We know that pubertal hormones affect the oscillator coupling in the suprachiasmatic nucleus. We also know from the classic work Mary Karskadin did more than 30 years ago that if you control everything else and look at kids as they move across pubertal maturation, they actually get sleepier. Their multiple sleep latency tests actually show greater sleepiness even if they get as much sleep. Now, this combination of factors is quite interesting. So if you think about the fact that as you are 11, 12, 13, you're starting into puberty, you're rapidly growing, you have these metabolic changes, your need for sleep and sleepiness are actually going up, if anything, and you have a slight tendency, because of these oscillator circadian changes, to prefer staying up later and sleeping in a bit later, a slight tendency. But consider those changes 100 years ago or 500 years ago. Imagine a 15-year-old reading by candlelight who's really sleepier and has a slight tendency to stay up later. How late are they going to stay awake? Not very. But of course, kids aren't reading by candlelight anymore. And so what's happened is these subtle changes in sleep and circadian systems at the onset of puberty now are being influenced by artificial light, by peers and social activities, greater freedom to select bedtimes, mobile technologies in the bedroom, stress and anxiety as you're waiting with the phone on your chest for the next text message about what's happening, even as you're going to sleep. And then the crazy school sleep squeeze of early school start times, a major circadian shift on weekends and vacation, then all the work, sports, homework, projects, use of medications and stimulants increasingly in kids. And you begin to get a profound set of changes in these systems, not because of the biology, because these subtle changes in biology are being amplified by a modern social context. Then there's this set of contributing factors and vicious cycle. There's catch-up sleep on the weekends, which pushes the circadian system much farther. Kids stay up even later on the weekends and sleep in later to catch up on the sleep. Increasing use of stimulants, increasing use of mobile technologies and blue spectral light at a time the brain thinks it should be dark. And then all this stress and emotional conflict and social evaluative threat that gets amplified as kids are now in middle school and worried about who they are and who accepts them and who likes them and how popular they are and what minor transgressions they've done. And all of this shifts arousal and vigilance in a direction counter to sleep. And then, as people have quantified, you get increasingly this phenomenon of social jet lag. So people's individual sleep times, the midpoint of their sleep on their free period is multiple hours later than the midpoint of their sleep on their structured work or school schedule. And that takes off intensely at puberty. This is an old slide from 2004. Till Ronenberg has probably 20,000 data points now showing the same pattern, that adolescence and the onset of puberty in contemporary society with artificial light shifts dramatically into this social jet lag situation. So one of the big questions that was emerging from this work is, let's say conservatively, you can argue what percentage of young people and adolescents in the US, in Israel, in South Korea, and in various parts of the world are sleep deprived or having suboptimal sleep, some combination of sleep deprivation, social jet lag, and erratic sleep-wake schedules. The question is, what are the costs? What are the consequences of having this disrupted sleep? And we have a lot of information about this. First of all, there's sleepiness, and that's the tendency to fall asleep. And that results in a lot of problems, including increased accidents. Young drivers are heavily overrepresented in late night accidents and falling asleep accidents. But there's also tiredness, which is more of a motivational shift. It's harder to make yourself do things when you're tired, when you're sleep deprived. Difficulties with focused attention, irritability, reactive aggression, decreased mood, and contributions to aspects of depression, including the patterns of reward seeking diminished, as well as decreased mood, negative synergy with alcohol effects, direct effects on learning. One of the reasons that sleep occurs is to consolidate not just memory, but procedural learning, including social and affective learning, which is so important in adolescence, and increasing use of caffeine and stimulants, the way most of us do to deal with our chronic sleep deprivation. The risk for obesity, it's not just that you like to eat sweet foods or feel better by eating tasty foods. It's actually a signal to the brain to store energy. It creates a metabolic shift that makes obesity more likely to occur. The effects on affect regulation, which actually we and others have been studying. It's been fascinating to understand this more deeply. But the more important issue at the big frame level is this contributes to negative spirals. It is that these interactions are affecting multiple components of these systems. And the main point here is, even if we didn't recognize how important sleep is contributing to these problems, it's an example of how a small set of biological effects at puberty, this shift in two aspects of the system, the sensitivity to light information and circadian as well as sleep, creates a spiral of negative effects. So you have these late night erratic schedules, you get sleep deprivation, erodes mood and motivation, that creates greater stress and affective problems, you're not controlling your emotions and you're missing school or sleeping in, interferes with sleep and arousal regulation, more problems falling asleep, the vigilance system becomes affected. This is an example of a social context, modern contemporary life in the broadest sense, including artificial light and 24/7 stimulation and access to social interaction, that's amplifying a very small biological developmental change. But it's resulting in a torrential spiral of behavioral impact that's influencing many, many aspects of health and well-being. Now that could be the whole talk itself, and that was a major focus of my research for a long period of time. But what's equally true is everything we just said about sleep applies to several other systems. Adolescence is a period of multiple vulnerabilities that are analogous to what we can measure and understand the mechanisms of sleep better than we can understand the mechanisms of other regulatory systems that have analogous changes at puberty, which set up other spirals. And if you look broadly, adolescence is this profound paradox. In most measurable ways, it's the healthiest period of the lifespan. Almost everything you can measure from elementary school age through adolescence gets better. Strength, speed, reaction time, cognitive abilities, immune function, resilience to stress, injury, accidents. But what happens to overall morbidity mortality between elementary school and the end of adolescence? It jumps 300%. Why? Because of accidents, suicide, homicide, depression, alcohol and substance use, and on and on and on. It's behavioral and emotional problems that emerge in adolescence. So this brings us to a larger frame of this integrative developmental science, of thinking about this window of this inflection point, this transition into puberty, as potentially a modifiable window related to not just the sleep spiral we've talked about, but to other spirals. And that's been the focus of a lot of our work over the past 10 years. But I want to spend a few minutes creating a bit of a way of thinking about developmental trajectories and developmental science. And I want to take something very simple that's easy to measure and easy to understand. Individual differences in adult height. This happens to be the world's tallest man, 8 feet 9 inches tall, meeting the world's shortest man, 1 foot 9 inches tall. And you can think about 100 reasons these two could be individually different in height as adults. You can think about genetic factors, you can think about nutrition, you can think about early environmental insults, you can think about endocrine disorders, you can think about diseases. There are many, many factors that contribute to adult individual differences in height. But ultimately, what we also know is that those individual differences in adults follow a developmental process. And if you look at the simplest level, these are the classic growth charts that all pediatricians use. It looks like that these are, like this is age 2. It looks like this increase in height is a pretty linear process. There's something in here, this is about puberty, you can't see much, and then it tapers off. But if you look at, instead of height changes at population level, height velocity, individually measured changes in height from time 1 to time 2, you get height velocity. And this shows a somewhat different picture, which is that if you look at the number of centimeters per year individuals grow, the first year of life is a time of profoundly rapid growth. And then growth continues, but it slows way down across from about age 1.5 to 2 until about age 11 or 12 in boys and 10 or 11 in girls. And then there's, boom, this sudden increase in height velocity, and then it peaks and it comes down. Now again, this isn't some mysterious process of being a certain age or being a certain grade level. This is a biological effect. It's when you start puberty. And when it happens, it's not subtle. When you have someone in your house that hits puberty, it's a dramatic change. You can't keep them in clothes and shoes. It's hard to get enough food in the refrigerator. It is a dramatic, suddenly they need deodorant. This is not a subtle set of changes, okay? And yet, if you don't look at this from the right angle, you could completely miss this if you just looked at the growth curves. But there's another part of the story that I want to emphasize. That for what we can show in height, we could also show is affecting dozens of other systems. Because at the same time, when you see this, what was decreasing rate of growth suddenly shooting up, is affecting not only facial structure, body shape, the development of menarche and pubic hair and breast development, but it's also affecting neural systems and probably gene expression. There are so many other aspects of developmental processes that are being impacted by this window of development that are harder to measure than height velocity, and probably no less important and perhaps more important. And this is the summary slide of how I think about the developmental science of adolescence. It's a perfect storm of interacting levels of change. In the same way we looked at height velocity, rapid physical growth, it's also the activation of new drives and motivations, sex-specific changes in facial structure, the face that you see in the mirror when your face is suddenly changing at puberty, the shape of the faces of all your friends, voice changes, body characteristics, changes in sleep and circadian regulation, as we've talked about as one example, metabolic changes, a wide array of cognitive and emotional changes, and then profound changes in social motivations, social contexts, and social roles. Oh, and then, of course, figuring out how to relate to the world and yourself as a suddenly and mystifyingly sexual being. This is a lot of challenge at multiple levels. And the point here, I have neurodevelopment in red, but the point is if I put bidirectional arrows between every system that influences the other level, peers, family, school, culture, media use, you couldn't see the words because the arrows would obscure it. Every change from the deep molecular changes of biology to neurodevelopmental changes are going to influence the tendency to be interested in certain kinds of peers, the tendency to use certain kinds of culture or media involvement or experiences in school. But those experiences, of course, come back and affect neurodevelopment. So you have these bidirectional interactions, which creates a dynamic period of change across multiple levels. Now, this is a slide from a paper Evelyn Cronin and I did in 2012 in Nature Reviews Neuroscience, where we were really trying to think about puberty-specific changes in brain development. And actually, this was part of a meta-analysis of some imaging studies at that time on adolescent brain development. And actually, we had some sort of friendly disagreement about the relative importance of puberty at the beginning of this process. It's become a wonderful collaboration over the years. And it was, again, a really key time when my interactions with Avi and our understanding of the puberty-specific changes in sleep was both an example and an analogy for a lot of what we were thinking about in these broader neural systems. And the idea is that, in fact, most aspects of neural development don't really care much about puberty directly. They don't show much changes if you look at kids that are similar age and grade level but difference in puberty. But the systems that do seem to be influenced directly by puberty are primarily these deep structures and their circuits in the brain that are involved in social and emotional processing. As puberty happens, which is a relatively early, there's the pointer. It's a relatively early process and has been happening earlier in recent history over the last 100 years. It's primarily influencing these affective and salient systems in terms of social cues and context, and the subcortical structures that are primarily involved in affective regulation, which of course interact with all of these higher frontal cortical systems. We felt strongly that the data do not support the idea that a weak prefrontal cortex is the answer for why adolescents behave the way they do, because in fact, adolescents can recruit their prefrontal cortex quite well when they're motivated and engaged. In fact, think about who's going to learn a really tedious technology task, a new technology faster, if it has social media impact, an adult or an adolescent, and we don't have to run that bet. It's the ability to engage frontal cortical systems is strong. It's that what creates the engagement that is a key part of this story. And so this set up this idea of this inflection point. The same spirals we talked about with sleep are actually quite relevant to both the negative spirals that emerge, all of this morbidity and mortality, excessive risk-taking, substance use, depression, social withdrawal, but also for positive spirals. It's a time when kids become passionate about goals, about meaning, about having a positive impact in the world. And we think about this out to mid to late adolescence, years later, when these trajectories, the positive trajectories are well established, or the negative trajectories are well established. But the inflection point might be earlier than we expected if we could understand these systems a little more clearly. And this became the focus of a lot of work. To summarize many, many different kinds of studies, we believe, in both from this meta-analysis as in a variety of studies in a number of labs following that paper in 2012, that adolescent brains are not deficient or inadequate compared to adult brains. In fact, we think they're very well adapted to the tasks of adolescence. There are unique opportunities for social, emotional, and motivational learning. It's learning, the kind of learning that seems to be facilitated after the onset of puberty isn't just cognitive flexibility, probabilistic learning. It's about complex social evaluative processes. And that's what they should be learning how to navigate these hierarchies, social rules for gaining acceptance and status, and this mystifying discovery of a sexual self. And a particularly practical part of this work, tied to puberty-specific changes, is this extra sensitivity to feelings on the positive side of social evaluative threat or admiration. The desire to be admired, yes, kids want to be admired, adults want to be admired, but the intensity of wanting to be admired and valued goes up, and the intensity of the negative emotions of being disrespected, rejected, or devalued goes up. Everyone in this room can remember, likely, some experience when you were 11, 12, or 13, and you had some minor embarrassing event, and it is burned in your brain as the most humiliating feeling. You can still remember the feeling. The brain shifts into that extra sensitivity in this period of time. Transgressing a minor social rule or having somebody belittle you and disrespect you becomes an intense affective experience. And that signal has salience to our decision-making and to our learning. Now, these sensitivities for these social evaluative feelings, we think, create both opportunities and vulnerabilities. This idea of social affective or social emotional learning in adolescence, I love this quote from Frederick Buechner about adolescence. We search on our journeys for self to be, other selves to love and work to do. And that Maya Angelou quote that I started with is particularly intensely important to adolescents. They care deeply. You can give them great information, you can teach them exactly what they should do, the skill, but if you do it in a way that implies that they don't know what's good for themselves or that they're irresponsible or not mature, that can contaminate the message to the point that they're much more likely to rebel or push against the information. This has been shown in some really clever studies. David Yeager has really done some elegant meta-analyses of behavioral interventions that work at younger ages and older ages, and they backfire in mid-adolescence because of their sensitivity to implied disrespect. If you tell them what they should do to be a healthy eater, if you tell them what they should do for exercise or their sleep, but somehow imply they don't know enough to make those decisions themselves, it will be not only null effect, it can actually be iatrogenic. And I could say a lot more about that example. But this idea that between ages 10 to 14, but it's not being a certain age, it's the beginning of puberty. This onset of puberty begins a set of neural changes in social and affective processes. It lines up pretty well with what in the US education system the teachers call the 5th grade slump and the 8th grade cliff, when kids, particularly disadvantaged kids, become increasingly bored and disengaged in school. And in fact, there's a large analysis showing that in US schools, more than 55% of the kids reported being bored at school most of the time in 7th and 8th grade. It's the peak of boredom. They are not interested in learning and sitting at their desk and focusing. They're interested in social the incredibly intense and interesting social emotional interactions and relationships that are going on around them. That increase in sensation seeking and this desire to engage in social learning is the driver. And by making them sit and do work at the desk, they're going to be really bored and disengaged. This is a key time when so many kids fall off the educational trajectories, and not just in the US, around the world. We think that this window, as they're beginning to have the slump and 8th grade cliff from education, is also a time many other parts of these early spirals are beginning to be shaped in this way, in ways that can be influenced by the right kinds of honoring their desire for status interventions. And it's one of the things that's interested me the most over the past several years, this idea that one component of motivational learning, motivation isn't just making yourself do something you don't want to do. It's what do you fall in love with? It's the difference between somebody who makes themselves read literature to get an A in their English class and somebody who hides under the covers to read great literature because they've fallen in love with literature. It's this heartfelt goals and values that are shaped so strongly by these experiences in early adolescence. Now, we've been very interested in the developmental science approach to these multiple levels of bidirectional interactions, these dynamic processes over time, not only because of their interactions across these levels, but because the patterns of experience, not a single experience of reading a great book or having an inspiring teacher or coach say something, but the patterns, the repeating patterns of experience and having success and challenge are actively shaping. They're actively sculpting the patterns of connection among these developing neural systems. And that idea has been intriguing to us, and we think that the onset of puberty is another window of plasticity, and we're beginning to get a deeper understanding of what kinds of plasticity are emerging at the onset of adolescence. And I'm just going to give you one example from a paper that came out about 2 months ago in Nature Neuroscience. And again, there are going to be a number of other studies using other approaches and graph analyses, but this study was looking at functional connectome distinctiveness. And the idea here is that patterns of connection in our brain as adults are actually quite distinct. In fact, this figure is from Adriana Galvana's commentary on this paper, sort of giving this image of an adult fingerprint. The functional connectivity in each of our brains is quite unique. But the distinctiveness across individuals is not well established by even mid-childhood. And this study actually quantified connectome distinctiveness, like looking at across 2 different tasks as well as resting state, how distinct was the functional connectome across, and this is a group of 797 individuals. And what's interesting, this is age 8, with about, the quantification is about 15 to 25% distinctiveness, and it shoots up to about 65%, which is about adult levels, 65 to 70% adult levels by their quantification, by age 17. And interestingly, in females, which is the orange, it's about a year and a half earlier than males, which is in blue, which is girls go through puberty about a year and a half earlier. This is one of several studies I could show you that's consistent with this idea that the basic individual differences in the patterns of connection in our brain are being shaped during adolescence, and probably more sharply as these strong feelings and sensitivities about social and affective learning are intensified during, after the onset of puberty. We like to think that we sort of pose the question this way. So does the onset of puberty initiate, in essence, a growth spurt in social, affective, and motivational learning? Of course, the foundations of social and emotional learning are much earlier, and the first couple years of life are the foundational part of that, and there are many, just like, that's the reason I show the growth curve. Of course, kids grow incredibly fast in the first 2 years of life. There's tremendous growth long before they reach adolescence. But is there an extra spurt of learning in social and affective and motivational systems at the onset of puberty? And we think the evidence keeps getting stronger and stronger that it's true. I'm going to give you a couple examples. This is from a study we published in 2014. It's from a Pittsburgh longitudinal study. We took kids closely matched in age, but differing in pubertal status, girls aged 10 to 12, boys 11 to 13. We restudied them 2 years later. We had a whole battery of behavioral tasks, computer tasks, and imaging tasks. This is just one paper. Jeff Spielberg, who was a postdoc working with me when we analyzed this data, is the lead on this paper. And it's one of those sets of findings where it's so deeply rewarding because it fits with what you predicted. And this interest we had in what's changing in fear reactivity at the onset of puberty. And we and others had data that suggested that, in fact, fear reactivity tends to go up, including fear-potentiated startle. Age-matched kids, some of them more pubertal, were actually more likely to have greater fear reactivity. And people would say, that's counterintuitive. Kids are getting bolder, they're taking more risks. What do you mean their fear reactivity is going up? We think this study actually helps us understand why both things are true. And that is, yes, and this happens to be just amygdala activation to threat faces in a Harari task versus shape matching. But we have other data that are consistent with this. But the point is that it's not just that amygdala activity is higher, but nucleus accumbens activity is higher, and the coupling between the two go up, and both of those changes correlate with the amount of testosterone increase in both the boys and the girls, not their age. It's puberty and testosterone increase. And there's decoupling between orbital frontal cortex and the amygdala that's also correlated with testosterone going up. And there are adult studies, in fact, the Dutch study actually administered testosterone, also showed decreasing coupling between OFC and amygdala in a double-blind placebo-controlled challenge. So this idea that as puberty starts, and as testosterone goes up for the second time, it's high in infancy, that is shifting brain systems so that it's not just that they're more fear reactive, it's that they're more likely to activate fear and reward activation. And what else is a thrill? I mean, you can't have a thrill without fear. Kids don't go on roller coasters and go to horror movies because they're fearless. They go because it's thrilling. They approach things that are frightening, and this makes a great deal of sense in the social ecology of adolescence and what's happening as they become more sensation-seeking. As Mark Twain said, courage is not resistance to fear courage is resistance to fear, mastery of fear, not the absence of fear. It's not being fearless, and every culture that's been studied admires courage. If we didn't have courage to deal with difficult issues and threats, we wouldn't have survived as species and across cultures. It's not being fearless, it's learning how to approach something when the opportunity to show courage is the fundamental learning task happening increasingly in adolescence. Now, we've done several other studies and many others. I'm just going to give a couple examples trying to understand the mechanistic level processes that are contributing to these social and affective changes. Wouter van den Bos, who I was actually a graduate student in Evelyn Krohn's lab, who's now at the Max Planck Institute, was working with us during his postdoc in California, and he was doing some work looking at how testosterone correlates with overbidding in an auction task. What happens is, you basically have this computer task. If you think you're playing against the computer, you optimize your bidding to get the most money. But if you think you're playing other people, and only the winner gets announced as winning the auction, you overbid because you like to win. That's why people bid too much in real life. They don't like to lose. And it became a really interesting computational task where you could look at how much people are willing to pay to get the status of winning the auction. And what happened is that correlated with testosterone. We adapted the task for younger kids, and in a paper that came out about 2 months ago, Stephanie Cardus is the first author, we did this in early adolescent girls who also have sharp increases in testosterone as they start into puberty, and showed that, again, their overbidding, willingness to give up money to win the auction was related to the rise in testosterone. A couple of other papers out of Evelyn Krohn's lab has been showing in longitudinal large studies that adolescent peak in nucleus accumbens activity, a critical role of pubertal hormones in both the risk-taking tendency and reward sensitivity. Dreer et al. Showed in a testosterone administration task that it increased both pro-social and antisocial status-enhancing behaviors. Now, it's not just about testosterone, but testosterone happens to be a tractable slice into this complex set of processes. And we shouldn't think of testosterone as just a male hormone. It and its conversion between estradiol is playing a role at puberty to sensitize neural systems to social status and prestige, being admired. You become sensitized to whether you're being admired and respected. And it's not just, obviously there's other hormones involved in this social motivational learning, but this is an important part of this larger picture we're understanding behaviorally. This extreme sensitivity to being admired or disrespected becomes amplified, just like the growth velocity becomes amplified. This is a learning signal to pay attention to certain kinds of feelings and experiences. So to sort of jump cut beyond a lot of the empirical papers to trying to put this together in a more integrative way, as we've been trying to understand what pubertal hormone potentiation is doing, first of all, we think the evidence is strongly supportive that sensation seeking, that is, liking high-intensity, more arousing experiences that happens in early adolescence is specifically tied to pubertal hormones. And this capacity to experience fear as a thrill and learn to approach it, even though it's frightening, is potentiated by these hormones. There's increased interest in and engagement in social learning. It promotes risk-taking in pro-social as well as dangerous ways. The majority of risk-taking in early to mid-adolescence is not jumping out of dangerous, moving vehicles or risking your life. It is raising your hand in class, asking someone out on a date, telling someone you like them. It's going out for a sport. It's going out for the play. It's running for office in your class. Those are incredibly risky things to do. If you didn't have a proclivity for risk-taking, we wouldn't have a lot of the pro-social changes. There's also intense attention and motivation for gaining and losing admiration, respect, acceptance, belonging, and status. And these create intense feelings. The key part of this, to sort of sum up, is that we don't think the biology is the fundamental thing that's changing behavior, any more than biology was what it was changing sleep. Subtle changes in the biology are sensitizing these systems to social and cultural contexts. The reason I have this photo here on the right is one of the most fun experiences I had is we had a meeting that Richie Davidson organized with the Dalai Lama, and we were meeting with Tibetan Buddhist scholars about education, and I was talking about some of these data, and they laughed, and I had to wait till the translation occurred, and they said, oh yes, because we see in the Tibetan Buddhist monasteries that the kids compete like crazy at this age, but they compete to show they're more kind and empathic and compassionate than any other kid. And they laugh because they see it. I mean, and that's the prestige criteria. If that's what's going to get you admiration, then you're going to practice. But if you spend those 2 or 3 years practicing to show you're kinder and more compassionate than the other kids, that's going to shape your brain. But that's not just true for this extreme. It's true for every cultural value that feels salient to those kids. Who's shaping those feelings in our society? Those are really profound questions. This is another interesting area of this work. This is the Fearless Girl statue, which appeared on Wall Street, which is quite emotional in our current political state in the US. But it raises this issue of the intensification of gender differences and gender inequality that happens at this age around the world. And we think that it's not that the biology is playing a big role. It's that if you are a boy in a society that admires bold, aggressive behavior, but a society that does not admire that in girls, then the sensitivity to status is going to drive differences. And these are gender inequality index around the world in color codes. These are testable hypotheses. We think the learning is sensitized to shape these differences, not that the biology plays a big role. And it's that the gender inequality is amplified by these cultural influences at this key window of time. This has important implications around the world. I'm going to finish up. I normally walk through one of my favorite examples of the high-intensity social-emotional learning part of this, of a boy noticing a girl he finds strikingly attractive, immediately smitten. They flirt a bit, and he departs the scene with a kiss followed by a second kiss. They've exchanged less than 100 words, yet both are swooning with sensations of falling desperately in love. And then, of course, they can't stop thinking about each other, longing, obsession, and desire. And at this point, all mental processes, thinking, planning, goals, priorities, emotions, and motivations have been transformed by this brief encounter. And now each would happily forego food, sleep, comfort, and all competing pleasures simply to be in each other's presence again. So, of course, they managed to get together a second time, clandestinely, and now romantic feelings accelerated at a feverish pitch. And soon they wish to be together till the end of time and feel as if the entire universe meant for them to be together. And at this point, every motivational priority has been realigned. They're willing to risk destroy family, dangers, transcend pain, just to be together. They feel as if life itself would not be worth living without the other. All this that they just met 4 days previously and barely know each other. Now, without some empathy for the high-intensity feelings that motivate this kind of behavior, this story would sound utterly ridiculous. But it's actually the most successful tragedy in Western literature. Now, this has resonated across cultures for many centuries, across many translations, because it's the recognition that adolescence creates these intense passions and shapes extreme versions of this kind of learning. And we believe that the same high-intensity social affective learning that is captured in this anecdote can shape high-intensity motivational learning in many other ways. Again, I talked about this growth spurt. We think that this pubertal learning spurt may actually be an intense time for learning about intense social bonding and a different kind of attachment and motivational learning. And we don't use the word love very often in science, but I think it's not an unreasonable word to use to think about this capacity for high-intensity motivational realignments. Because falling in love can be literal, like Romeo and Juliet, but it also can be a metaphor, falling in love with literature, dance, music, a particular religion or philosophy, the idealistic ambition to make the world a better place with math, science, social justice. And it's also an incredibly dangerous time because these abilities to ignite passions that can create love can also create hate. And this intense social affective learning and these spirals create the high stakes concerns about what's happening increasingly in the world, the increasing number of adolescents and the increasing number of adolescents in dire social and economic circumstances, more than 2 billion adolescents in the world, more than have ever existed in a higher proportion, and most of them in low and middle income countries with not great prospects for succeeding economically as adults. So we think that this high-stakes pivotal transition from childhood into adolescence is an incredibly rich area for deeper understanding, even more parsing of these complex, neuroscience and genetic influences that are shaping this rapid dynamic period. We think it requires transdisciplinary teams working in this area of developmental science to understand the mechanisms, the actual processes. But at the same time, we need that integrative understanding to be directed at applying those advancing insights into identifying modifiable factors, the timing, the developmental timing, the targets, and the inflection points, and matching those early interventions to optimal developmental windows. We think of this as precision public health and education to really understand how these sensitivities can create opportunities for the right kind of early intervention and prevention and promoting positive trajectories. And we really look forward to the next 10 or 15 years, many teams working on these processes. And I think it's also a wonderful way to think back to the work on sleep as a direct contributor to amplifying some of these negative spirals and as a window of opportunity for early intervention, and how the mechanistic work, understanding the puberty-specific changes in sleep, became a metaphor for this broader set of work that we're currently engaged in. Thank you very much.
So we have time for a few questions if you have them, or was it all perfectly clear? So, questions? Anyone? Comments? Well, oh, yeah.
It might be a silly question, but I just, when I teach about puberty in my human development classes, the thing that's really interesting to undergraduates is this timing of puberty in our late bloomers. And do you have any comments about how that might?
So, yeah, so the pubertal timing issues are really a crucial part of this, and let me take three aspects of that. First of all, it highlights the idea that it's not being a certain age, that some of these processes are just fundamental. And we see that physically, obviously, whether it's the growth spurt or the secondary characteristics. But the same thing's going to be true if there are learning differences, if there are affective differences. And so understanding that it's a developmental process that varies. It doesn't match in any direct way with being a certain age or grade level. The second thing is that in addition to individual differences, and there's a lot of literature in terms of the advantages for boys being in earlier development and the disadvantages for girls, but that's a simplified story. The broader point is that puberty has been happening earlier. And this is not a subtle difference, and the data we don't have as good historical data on boys, but it's been happening certainly earlier in boys, but it's been happening much earlier in girls, and it's happening all over the world. But the other side of that is that if you think about what adolescence is, it's this awkward period between the onset of puberty and attaining full adult status in your life. That's happening later and later. So adolescence has always existed. Schlegel and Berry did this wonderful anthropological study of pre-industrial societies, and there was a period that was not childhood, not adulthood in every society that had been studied, but it typically lasted 2 to 4 years in hunter-gatherer pre-industrial societies. Now, you've got girls going into puberty at 9 and 10 years of age and not having adult roles and responsibilities until late 20s. So adolescence has been stretched out into a much longer period of time. We think that if you go back to that model from the Krohn and Dahl paper, that's those spirals, we think that creates greater opportunities for kids in advantaged environments to learn, explore who they are, explore relationships, learn skills, understand the world. It may amplify the opportunities for the positive spirals in well-scaffolded, well-resourced kids in good environments. But it probably increases the vulnerabilities for every concern that we have by stretching that out. And now the individual differences play out. If you're a really anxious, shy kid, if you're a bold kid, what culture are you in? What's the way you can get status and prestige? When you can jump out of a moving car on a bridge and post it on YouTube and get 1 million hits, that's a lot of prestige. But it's a bizarre way to get it. So there's a lot of factors that are interacting with contemporary life and these individual differences in puberty and the stretching out of adolescence. So again, it could be a whole topic in and of itself, but those are a few points in that area. Other? Yeah. So cross-cultural differences are huge, and we actually are doing work. We have a new Gates grant. We're working actually in 3 countries in Africa, and we actually have a project that Avi and Carol Worthman and I are working on in rural areas of Vietnam. There's a lot of cross-cultural work going on, and I would say the short answer is that cultural differences are huge in terms of what it shapes in these sensitive learning periods, but the principles seem to be more similar. And so they play out in very different ways. And so whether you're talking about sleep systems or whether you're talking about emotional systems or prestige criteria, those interactions can look very different for individuals. And so I think that and then there's also cultural differences like, like if there are gender differences in what kinds of freedoms are granted, for valuing education, for valuing technology. So there are many, many interactions where the cultural messages at an implicit level, at this feeling of what matters, are shaping these processes. And then obviously there are also differences in terms of restrictions and behavior and factors. So I think from my perspective, it's why I used the sleep example to begin with, not only because that's where I worked early. The biology contributions are actually quite small in many ways of quantifying it. It's the social and cultural influences that create these spirals. And those are so different across different cultures and across different contexts. But the fundamental processes look very much the same in terms of how they work. And I think that's the sort of yin and yang to this. And so if we talked about a particular issue or problem, or if we talked about depression, or if we talked about suicide or risk-taking, it's going to look very different across different cultures. But the role of puberty and these spiraling patterns of behavior are probably very similar, but they play out in different ways. So great, that's a great set of questions. And in fact, I'm going to pause just for a moment. I think that the most important issue for me is these are falsifiable hypotheses. And so it could very well be that the period right before puberty is actually the best time for certain kinds of cognitive interventions that require certain kinds of cognitive flexibility learning. And in fact, there's some animal data Linda Wilbrick just published last week in Current Biology looking at these inhibitory neurons at puberty, giving the hormones early actually start to close that. But for social and affective learning, it begins to be sensitized and maybe amplified at the onset of puberty. But that doesn't mean it stops. I mean, those hormones are staying high for years. And the difference in these hormone levels between young adults and mid-adolescents are not that different. But it's probably not the level of the hormone. It's probably the change in the level of the hormone that's the biological signal. But again, it's not categorical. We need better learning models. So when I first started putting this model out, I remember having this intense conflict with Jackie Eccles. And she said, you're wrong. It's earlier than that. And first of all, she was thinking adolescence meant teen, not that this sort of 10 to 14. And secondly, she was saying, but their hobbies and interests are shaped earlier. And I said, yes, that's like having a crush, but that's not like falling in love, like you're willing to die for someone. So and it doesn't mean that biology makes you fall in love. It just creates the capacity for the high intensity motivational learning. Whether that happens at 13 or 18 or 25, let's say, I don't think it's like the growth spurt. I don't think it's so biologically determined that if you don't get it then, it's not going to happen and you're going to close your bone plate. But that intensity of these feelings being activated, the potential, I think is dimensionally different than what happens earlier, in the same way that you can have a crush on a teacher or a friend, but it doesn't make you think life's not worth living if you're not with them after 100 words and 2 kisses. So I think this I think it's this continuities and discontinuities. But we need to put rigorous models out there and test them. And it's great to be wrong. I mean, but it still lets us match the right kind of intervention to the right sensitive period. But if we don't try, if we treat everyone from 8 to 18 as an adolescent and run them all through an imaging paradigm and say, adolescents do this, I mean, we're going to miss windows of opportunity for particular kinds of learning. And that's really the focus here is let's put out a model, take our best theoretical shot at what we think is happening from the data, and then design experiments. But not just experiments in the lab, intervention studies in real-world gnarly problem areas.